Hey, hello, I'm Alan Sundo. I'm the Global FA Leader of LTW. Hey, before today, are you familiar with Amphenol LTW? If not, let me give you a quick introduction. Founded in 1993, Amphenol LTW has over 30 years of experience in connector design and manufacturing and holds 300 patents worldwide. As our reputation has grown, we have expanded in several facilities, such as in Taiwan, China, Mexico, and plan to expand in other regions, living with our commitment, where our customers are, we are there. In addition to ISO 14001 and ISO 9001, we are also part of IATF 16949. Our laboratory Hey, hello, I'm Alan Sundo. I'm the Global FA Leader of LTW. Hey, before today, are you familiar with Amphenol LTW? If not, let me give you a quick introduction. Founded in 1993, Amphenol LTW has over 30 years of experience in connector design and manufacturing and holds 300 patents worldwide. As our reputation has grown, we have expanded in several facilities, such as in Taiwan, China, Mexico, and plan to expand in other regions, living with our commitment, where our customers are, we are there. In addition to ISO 14001 and ISO 9001, we are also part of IATF 16949. Our laboratory is the first connector manufacturer lab in Taiwan to be certified with UL Witness Test Data Program. With ULWTDP facility, you can certify your connector, or we can verify the connector, such as UL1977 and 2238. Our lab is also certified under Taiwan Accreditation Foundation Lab as a testing laboratory. Importantly, we have our own mold department capable of manufacturing and designing molds. To further ensure quality and to improve efficiency, we have implemented semi-automated and automated production line for many years now. Would you like to visit our factory? You'll be welcome to do so. For over 30 years, our product line now encompasses 27 categories, such as, first, we offer a complete range of M-Series circular connector solutions. Second, our circular connectors comes from different locking methods and materials. And lastly, we offer a wide range of I/O connectors such as RJ45, USB, and more. We also serve different markets such as marine, industrial automations, and heavy equipment. At Amphenol LTW, You are in a one-stop shop for all your applications. All right, are you ready for today's seminar? Believe me, it's going to be interesting. If you have some questions after the meeting, please feel free to drop by on our website. Thank you.
Okay, good morning and good afternoon, everyone. Welcome to join our webinar today. I'm Winnie and this is Amelia.
Hi, I'm Amelia.
And also, we have our FA Julian with us. Hey, Julian.
Hey, good morning, good afternoon, everybody.
Yeah, and
Julian.
hi, Julian.
You look a bit green.
Yeah,
Okay, and before we dive into today's topic, that we would like to give you a short introduction of Amphenol LTW. So our headquarters is in Taiwan with factories in China and Mexico. And we've built a strong foundation over decades in rugged waterproof interconnect solutions. And since 2010, that we've been part of Amphenol. So you can count on global expertise and certified quality.
Right. And a few numbers to frame it. We offer 24 and more product series, over 70% and customized solutions, and 50% of them are automated produced. Our connectors serve 35 and more market applications such as marine, LED, automotive, and especially data center solutions. Plus, we work with 75 and more distribution channels. So it's easy for all of the customers to reach us.
And let's get started with today's webinar, Enabling the AI Revolution, Solutions for Next-Gen Data Centers.
I will be playing as a trainee in this session. So if you are a beginner in this product series, we will guide you through with a steady pace.
And in this webinar, we will cover modular I/O solutions and SnapQD series for two major approaches to liquid cooling in data centers, and that are immersion cooling and cold plate cooling. And Julian will provide background on the data center transition with us.
And don't worry, we promise to keep it engaging. If I can follow through as a trainee, you will leave this webinar as experts in next-gen cooling solutions. Okay, then Julian, it's your turn.
thank you. All right, let's take a couple of minutes just to put the basics on this question. So first, we'll introduce some customer-centric key metrics. So as a lot of you know already, I'm really a cyclist enthusiast, and I know what power means. In that way, I'm just thinking that every watt of power counts when I climb a mountain, when I want to be the first at a sprint. So here, it's basically the same for data centers. Every watt of power counts. Every watt of power must turn into computing power. So today, we want to see how efficient can be a data center. And for that, we have key main metrics. So in terms of operation efficiency, we'll have first and the most important will be power usage effectiveness. So it's just the ratio of your total facility power over your IT equipment. And ideally, everything turns into IT computing power. Therefore, the ideal value is 1. Data center infrastructure efficiency is the inverse of PUE, and it just means that 100% of your total power would be computing power. And when we discuss about heating, we need to reuse as much as possible every power that is lost into new computing power. So here, energy reuse effectiveness will track how much waste you are reusing. Yep. So now, just what are the key leverages on making sure that your data center infrastructure is as efficient as possible. So here is a very, very simple data center representation, and we'll focus today on two main key leverages. On one side, you have the interruptible power sources, UPS, or the power distribution units, the PDUs. On this side, the power conversion will be a very big challenge, but here it's not the subject of today. We'll tackle this problem a part of Amphenol Industrial, and we can support this work with a lot of other sister companies. Today's subject will be about immersion cooling. And for that, I just lay out a small example on what are the different technologies, but also what results and what how efficient could be here an immersion cooling structure. So we start with a small, very small, 1 megawatt data center computing power. We'll choose then our cooling method. Would it be air cooling, single phase immersion, or two-phase immersion cooling? And now, just to calculate quickly a total facility power, and I just would like to mention that this illustrates the best case scenario for total facility power and for the power usage effectiveness, but it's roughly in the range of what could be achievable in the next few years. So here you see that you already win and gain almost like 50% of power usage effectiveness going through from air cooling to two-phase immersion. Okay, so here, just to give you the latest update, and I think everybody saw this picture from Mark Zuckerberg. So this is obviously the Hyperion data center, which is superposed on Manhattan Island. So here we are talking about like up to 5 gigawatt. So you can imagine that on bigger structure, when we can earn this 50% efficiency, we will be able to turn first this 50% into new computing power, but also we'll save a lot of energy. So that's the reason why it describes and gives you a snapshot, and Winnie and Amelia will explain to you, but we give you here a snapshot of like how the market share have evolved between immersion cooling applications, from air cooling applications, obviously, to immersion cooling application.
Yeah, thanks, Julian. And let's summarize, because AI and high-performance computing workloads are driving servers toward higher power density and tighter racks. Therefore, liquid cooling is rapidly gaining market share in new high-density deployments.
Right. CPUs and GPUs, they keep pushing thermal design power up, and the racks are packing more accelerators per node. So operators are adopting immersion and cold plate solutions to remove the heat closer to the source and keep power usage effectiveness stable. In fact, liquid cooling's share of new high-density deployments has risen to over 30% since 2023, with the strongest growth in cold plate applications.
And beyond performance, operators care about energy use, reuse, uptime, and serviceability as well. And that's where quick leak-free interconnects and modular I/O make a real difference.
You're right. The server roadmap is clear. We want more power, more density, more efficient cooling, which brings us to the applications that the connector choices to make it possible.
And that's right. And let's move from trends to the solution stake. And liquid cooling, actually, it's not just a product, it's a solution. It's how we meet the demands of modern data centers, where systems need high speed, high bandwidth, and efficient data transfer to keep up.
Right, and those demands come from AI, IoT, and cloud computing, plus fast-growing workloads at the edge, 5G, and Industry 4.0.
Yeah, and that's why we focus on the whole system, from interconnects and distribution to a service model that keeps everything reliable and easy to maintain.
So the message is, choose the right building blocks to deliver the speed, bandwidth, and efficiency these applications need.
Yeah, precisely. Leak-free, quick to service, and stable high flow, so performance stays up and downtime stays down.
That's why liquid cooling is a solution, not just a single part, which means the right outcome depends on matching each application with the right building blocks.
Exactly. And let's map those applications to products and show how our customization capabilities make the solution fit perfectly. And all right, we will show you some key building blocks for liquid cooling in modern data centers. And Amelia will cover what the application is, and I will jump in with which connectors make it work. So listen carefully.
So let's go with immersion first. There are two types, single phase and two phase. Single phase is simple. You fully submerge the server, the coolant carries the heat to a heat exchanger, and cool liquid will come back in. Two phase is clever. The fluid boils at a low temperature for 50, 60 Celsius degree, and the vapor will carry the heat away. Then it condenses and drips back, so it's clean and it's efficient.
You're right. And for connectors, for power connectors that we can go big here, busbar connectors up to 1,400 ampere, and it's complying with IEC standard. And for data and control, that you've got the usual suspect, like you can use USB, RJ45, M12, DSOP, HDMI, DisplayPort, and everything you need to monitor the tank and keep it talking to the rest of the site.
And the next one is chassis level cooling. Think of it as a two-phase cold plate or evaporator mounted right on the CPU and GPU. It's cooling at the source.
Yeah, you're right. And for power that we use, busbar clips from 20 to 50 ampere, and they are compact, service-friendly. And for data that stays familiar that we just mentioned, like USB, RJ45, M12, DSOP, HDMI, and so on for controls and sensors, and also the service ports as well. And for this, for plug and play for the operation teams.
The next one is the mainstream right now. The cold plate liquid cooling, it runs through metal cold plates that's bolted right onto the hot chips. So it's super common and it's super effective.
Yeah, for data, and it's usually 2 to 6 pin connectors under 5 ampere applied to like fans, sensors, a little auxiliaries, and so on. And for the liquid loop, this is where SnapQD shines. Non-spill, high flow, quick to service on manifolds and cold plate lines. And we will go into SnapQD in details later.
Right. The next one is CDU, also known as Coolant Distribution Unit. A CDU is like a traffic cop. It moves heat from your IT loop to the building chilled water, and it handles temperature control, flow control, and filtration, so your inlet conditions stay safe always.
And on the data side, that you can use 2 to 6 pin connectors with rated currents smaller than 5 ampere for telemetry and controls. And for liquid, again, SnapQD, so techs can service, supply, and return lines quickly without spills.
And of course, the early warning system also matter. Leak, pressure, and flow sensor, it can catch issue early to protect uptime.
And here you can use compact 2 to 6 pin connectors with rated currents smaller than 5 ampere as well, and clean harness, easy routing on panels and rails terminations.
So the rhythm is pick the application, Then pair the right power, data, liquid pieces. That way you hit your flow targets, your pressure drop budget, and your service model.
Exactly. And now that we've matched applications to parts, and let's roll into the next section. That we've introduced the market trend of liquid cooling, applications, and connectors. And when it comes to liquid cooling, that we need something much more specialized. That brings us to one of the highlights of today's session, our SnapQD series. And this is where we combine ease of use, safety, and high performance into an interconnect solution.
Right. I'm thrilled to meet today's star and can't wait for the intriguing content coming up in the next few minutes.
So first of all, SnapQD is the name that we use at LTW, but technically, its specification follows the UQD standard. SnapQD is fully compliant with the OCP UQD standard. OCP is also known as Open Compute Project.
So does that mean customer can actually find our SQD connectors listed on the OCP website?
You're absolutely right. SnapQD is part of the OCP ecosystem, which means it recognized and supported in the broader open compute community. And now let's see some key features of SnapQD. Laser codes for traceability and premium aluminum sleeves available in red for hot liquid and blue for cold liquid. Large handle length to operation. Desk flat non-slip design. Bump design for easy handwork. Customizable connection types.
So in short, think of it as a flat face valve with a push to connect design. It can offer high flow performance, no spillage, and full compliance with OCP UQD standards. That's the essence of SnapQD.
Precisely. And on this slide, that you can see the general spec that defines SnapQD performance. High stable flow for reliable cooling. Durability tested to 5,000 cycles. The material of the body is stainless steel, and the sleeve is aluminum. The operating temperature is from -40 to 120 Celsius degrees. And the material of the seal is EPDM. The maximum operating pressure is up to 20 bar, and the maximum burst pressure is 80 bar. And all of these pair with our flat face non-spill design to keep fluid loads low and uptime high.
I do notice something in the table. We're using EPDM for the seal. Is it because it works with the widest range of coolants, which includes the most commonly used PG25?
Exactly. EPDM gives broad chemical capability for PG25 and other typical coolant, so you get consistent performance without changing fluids.
Okay. And for SQD, you can also see that we've just mentioned the blue sleeve is used for inlet, the red sleeve used for outlet. So it is very easy to see and identify it at a glance.
Correct. And you will also see SQDB in our lineup.
What does B stand for, and what are the differences between SQD and SQDB?
Oh, it's a good question. The B stands for blind mating. SQDB uses a natural metal finish, no red and blue sleeves, and it's the blind mating version for UQD. It's designed for self-align and connect without precise manual guidance, where access is limited or modules are frequently swapped.
So the rest of the features, such as 5,000 cycles, temperature range, and the material of the seal are all the same as SQD, right?
Exactly. And now let's take a look at the product dimensions. And here you can see the detailed measurement for both the plug and socket.
So this slide is really for the engineering team, right? It gives them the numbers they need to plan installation accurately.
right? The precise dimensions ensure that SnapQD can be easily incorporated into manifolds, racks, or cold plates without surprises. And this level of details help manufacturers reduce trial and error during system integration.
And for non-engineers like me, I'll just call it the modern art in millimeters.
Well said. And also here, we show the product range of SnapQD and QDB. Each size is designed to handle different flow requirements, making it easy for customers to select the right solution for their system.
So whether it's a compact cold plate or a large-scale rack manifold, there's already a SnapQD size that can fit.
Exactly. And what's important to highlight is that all of these models are already released and available. That means customers don't need to wait. They can start integrating SnapQD and QDB in their cooling systems today.
That sounds very perfect. So the full range is not just on the product roadmap, it's already on the market and ready to deploy.
Correct. And on this slide, that we are looking at the flow rate chart for SnapQD, and this shows how much water the connector can move at different pressure drops.
A quick refresher, what exactly is flow rating?
Flow rating is simply the amount of water that passes through per minute. You can think of it like a pipe's throughput efficiency. The same idea as an air conditioner's airflow, how much volume that can push each minute.
Got it. And how do we read these curves?
2 key tips. First, for the given pressure drop, a higher flow is better. The second one is, the flatter the curve, the brighter and more stable the flow rate across different pressure levels. So a flatter line is equal to more efficient and more consistent performance.
So if SnapQD have flatter curves at the same pressure drop, they will move more water with less strain on the pump.
Exactly. And here's the headline. SnapQD's flow rates exceed OCP UQD standard, which proves their superior efficiency. In practice, that means steadier cooling, lower energy usage, and more headrooms for high-density loads.
So more flow, less pressure drop, and more stable curves, so servers stay cool always and pumps will not overwork. That's why these connectors matter in modern AI racks.
Exactly. And we also benchmarked Amphenol LTW SnapQD against 3 big names. Then we use brand A, brand B, and brand C, and take SnapQD 04 as an example.
Nice. Well, anything we should know about the setup?
2 notes. First, we are comparing flow at the same pump pressure drop, 20 kPa. The second one is the brand A is market leader.
So who moves more water at the same pressure drop?
At 20 kPa, LTW SnapQD delivers about 15% higher flow than brand A. And versus brand B and brand C, for the same flow, SQD needs less pressure.
Which in plain English means cooler hardware and less pump work. Either way, you win.
Exactly. And plus, the UQD compliant interface gives you standardized matting and easier integration across cold plate manifolds and CDUs.
So SnapQD has higher flow at the same pressure drop, lower pressure drop for the same flow, and it's an easy choice for energy and capacity planning.
All right. And on flow, SQD clearly sits above brand A, B, and C.
Flow looks great, but how about compatibility and handling when the clients, they want to mix the vendors?
A great question. And let's talk about cross-brand compatibility. And we will start with CV and mating force. So quick refresher on CV. It tells us how much fluid passes at a fixed pressure drop. You can think of it as a resistance, like a faucet fully opened. A wider throat, higher CV. A narrow throat, it means lower CV.
So high CV means the connector is less restrictive, right?
Yeah, you're right. And here are the key takeaways for everyone. Our SnapQD shows CV values that exceed the OCP UQD standard that we take. So we take SQD 04 as an example today. In our test, the highest CV comes from LTW's plug plus LTW socket matted together. And even in mixed pairs, we see a boost. LTW's plug plus brand B and brand C's socket, or LTW's socket plus brand B and brand C's plug can increase brand B and C's original CV performance. In short, adding one LTW side lowers the resistance of the pair.
So even when the customers wants to mix vendors, using one LTW side can make the whole pair flow better.
Yeah, you are right. And now, mating and unmating force the interoperability. Because we all follow UQD, LTW plug plus brand B and brand C socket, and LTW socket plus brand B and brand C's plug are fully intermatchable, no fit issues at all. But if you want the lightest hand force, that LTW plus LTW's combination is the lowest, which means easier installs and faster service.
So short version, higher CV than others, even higher when an ALTW side is used in mixed pairs, UQD compliance across brand mating, and the lowest mating and unmating force when it's ALTW to ALTW.
Exactly. And now let's look at the real application of SnapQD. And here we can see the SnapQD integrated into a manifold system. A manifold acts the distribution hub for coolant, and SnapQD ensures every connection secure, non-spill, and easy to service. And we see it using 1U rack system where space is extremely limited. SnapQD's compact size and ergonomic handle make it a perfect fit for these high-density environments.
So in a way, SnapQD is working on both sides. In the manifold, it guarantees reliable distribution of coolant across the system. And in the 1U rack, it provides space-saving, quick connections without sacrificing performance.
Well said. And then you can see it integrated into a 1U server liquid cooling cabinet.
So essentially, SnapQD allows data center to maintain liquid cooling even in space-constrained server cabinets. That means efficient thermal management without taking up extra room.
Exactly. And that's the big win for operators. More cooling power, less wasted space. And while 1U is all about compact design, and many data centers also rely on larger server configurations. Here, we see a 4U server liquid cooling cabinet. In this type of configuration, the cooling load is much higher, with more components generating heat.
So compared to 1U, the 4U cabinet requires stronger flow performance and even more robust sealing, right?
Yeah.
And SnapQD can handle that without any compromise.
Yeah, exactly. And whether it's small form factor or large scale racks, SnapQD ensures consistent cooling efficiency. And before we move on, we would like to show a short SnapQD video as a quick recap. And it will help you to reinforce how it works and why it's such an important solution for data center cooling.
Exactly. because sometimes video says more than slides. So let's take a quick look.
Okay, let's go.
Amphenol LTW is a proud OCP solution provider. Our SnapQD connectors are listed on the Open Compute Marketplace, offering reliable, drip-free quick disconnects for high-performance liquid cooling connectivity. SnapQD Liquid Cooling Connector. Engineered for user-friendly operation and superior durability, the snapped connector features laser UQD type and date code AL, premium plating, blue and red, large handle length to operation, desk flat non-slip design, bump design for easy handwork, customized connection type available. The SnapQD ensures unparalleled performance in cold plate cooling with flat face valves, push-to-connect design, high flow, no spillage, and compliance with OCP UQD standards. SnapQD VSPP connector. A robust quick disconnect solution designed for liquid cooling in data centers and industrial systems. The SnapQD VRPP connector features for secure and leak-free integration with manifolds and cooling loops, enabling efficient thermal management in high-density systems. SnapQD V blind mating connector. Designed for blind mating behind blades, the SnapQD V is ideal for tight, hard-to-reach spaces like server racks. It offers ultra-reliable, dripless quick disconnects that protect electronics and ensure long-term, secure connections.
So this is the start of today's webinar.
Yeah, you're right. And all right, that we've covered flow rate, CV, and melting force on the SnapQD and SnapQDB side. And let's switch gears.
Yeah, because the moment you put your hardware in a tank, you still have to get power and data in and out.
Yeah, exactly. And that's where our modular I/O comes in. Think of this as a robust all-in-one fit-through for immersion cooling. One compact block handles your connections and keep the tank sealed.
So instead of drilling a bunch of holes for separate connectors, you can bundle everything into one module. It's way cleaner and way safer.
Yeah, correct. And it's built for high-speed data, so control, monitoring, and networking stay snappy. And it's IP68, so you get real sealing for immersion use.
I do have one question. Can we adjust what goes inside?
Yeah, that of course is customizable to match your coolant and layout.
That sounds great.
Yeah, and with the interface sorted, that we will show how this snaps into real immersion setups alongside manifolds, sensors, and service routines. And here, you can see the different modular options we provide. They are designed with reliable sealings that can even pass high pressure tests. Each module is secured with 4 to 6 and 5 screws, ensuring a robust and stable installation.
So that means once it's installed, it's really solid and leak-proof, am I right?
Yeah, you're right. And it also supports both 1U and 2U module, giving customers versatile installation choices.
On this slide, we can see the connector options available for our I/O modules. What's great is that these are all standard products that we already offer, such as HDMI, D-sub, RJ45, DisplayPort, USB. And this means customers don't need to worry about compatibility or availability. They can integrate these existing connectors directly into the module system.
Yeah, and by leveraging our existing standard portfolio, customers can reduce deployment time and cost.
So the message here is clear. You can build on our modular platform and choose from a wide set of trusted connectors without reinventing the wheel.
Perfectly said. And that's the strength of combining modular design with our broad connector portfolio. And from the following pages that we will show you some success stories. Here, that we have an IT Datacom CDU and where SnapQD is applied. The CDU is the heart of liquid cooling, distributing coolant across racks, and SnapQD is critical when managing multiple loops.
So if customer needs to service or expand their CDU, SnapQD lets them do it quickly without draining the whole system.
Exactly, and that's one of its biggest advantages.
For this CDU application, the customer not only used SnapQD for liquid cooling, but also they integrated our standard products. You can see as N12, X-Lock, HS-Lock for the signal and power control system.
Totally, and that's the value we bring. We don't just provide a cooling connector, but a full portfolio to cover the entire CDU's connectivity needs.
That means customer can rely on one trusted source, Amphenol LTW.
You're right. And then here's an immersion cooling tank application. In this system, the entire IT hardware is submerged in coolant, and our modular I/O solution provides IP68 unmatted waterproof protection and the EPDM sealing to prevent coolant leakage while maintaining high compatibility with materials.
So this isn't just about connectors. It's about a complete macro solution that ensures safe operation in immersion tanks.
Exactly. And finally, let's look at a Blake server application. In this setup, the system relies on our M12 cable assemblies for signal connection.
So customer can use our existing M12 to handle signal needs in their system.
Exactly. Since we've finished today's introduction and we will enter the Q&A section. And if you leave your message in the chat room, Julian and us will be able to answer you promptly.
Let's have a look.
Yeah.
Okay. Okay, I see one question. Regarding the SnapQD, you mentioned you have 4 sizes. How to quickly select the correct size and spec?
Okay. Because for our SnapQD, we have 4 different dimensions, and for each dimensions that we have the specification for its flow rate requirements and also their performance at different pressure drops. So for that details, actually, you can go to our website and download the DN, and you can see the detailed specification, and you can select the correct one for your application.
Right. The next question is, are there many competitors in the market? So there are 4 or 5 main competitors in the market, taking about like 60 to 70% market share. And we've shown them in the graph earlier. That's the competitors we have and we consider to compare with. For the rest, as UQD, universal quick disconnect connectors or from a standard, there will be many, many competitors, all coming from China, from the US, from Europe as well. So where we have an edge as of today in the market is especially on the I/O modular solution, because as we believe, all the immersion cooling will be at the rack level someday, not only in tanks, not only for the full server. So that's the reason why we are ahead of the designs and trying to make sure that immersion cooling systems are going to the rack, providing solutions such as the I/O modular solutions, where all the products are IP rated, unmated. And then we are also thinking about providing other solutions such as optical connectors, power connectors such as bus bars at the rack level.
Thanks, Julian. And we see
There's another question come through. In addition to IT applications, are there any other applications for SnapQD products?
Yeah, the main application of SnapQD is IT facilities and devices, and with some usage in other applications such as semiconductors and manifold fields as well, and also medical. And any other questions?
Oh, there's another one. Why is UQD designed to be red and blue? I think I can answer this one.
Okay.
Because the red one is for hot liquid to go out, and the blue one is for cool liquid to comes back in.
Smart girl.
Okay.
And any other questions or?
Okay. I also have one question about I/O module, because we covered the compatibility of SnapQD, but what is the compatibility with I/O module for coolant?
Yeah, it's a good question. And the main material compatibility is quite good. The outer shell is metal, rubber is NBR or HMBR, and the thermoplastic is PA66. The material of the jackets is XLP and PU that you can select.
Okay.
Yeah, I think we can add that for any specific requirement, we can follow the OCP standard to test and to make sure that we achieve the right coolant compatibility, providing your customers or yourself are using a different type of coolant.
Okay.
Okay.
Thanks, Julian.
Thanks. And I think for any guest that you have any of questions that if you live in the chat room that we didn't see that or answer that, then we will reply you after the webinar. And for anyone that you have some new questions after the webinar, that you can just reach out to us or go to our website, and then or even contact with our distributors or even Julian directly, and then we'll be happy to help you with product inquiries. And as we come to the end of today's webinar, and let's do a small quiz to recap and check how much you've learned. Okay. Okay, first question. And what shift in IT server development is driving our story today?
Because AI superchips are pushing higher power density and using tighter racks. So air cooling is no longer enough and hitting its limit. So that's when liquid cooling comes in and gaining market share.
Yeah, correct. Correct. Okay, pass. And next, what makes our SnapQD and SnapQDB stand out?
So they both come in EPDM for the seal material, and they are OCP compliant. They can deliver superior flow. They are leak-free and easy to handle.
Well done. And how do we identify models at a glance?
So for SnapQD, you can identify them with the red one and the blue one. Red one for hot liquid, as we just mentioned, blue one for cool liquid. As for SnapQDB, if you see a metal finish, then it's the blind make type.
It's really good. And last question. What kind of real world cases did we share today?
So we cover case studies from CDU, immersion tanks to
what?
Blaze servers. Showing how our solutions are already in use in real world.
Okay, awesome. You passed the test.
And if I can follow along as a trainee, I'm sure our guests audience is leaving as experts today.
Well said. And thank you all for joining us today. We look forward to supporting you for your future projects with Amphenol LTW solutions.
Thanks, everyone. Have a great day.
Bye-bye.